They thought the Mustang had reached its limit. The Germans had measured its speed, memorized its weaknesses, and believed they knew exactly how to fight it. But then, almost overnight, everything changed. The same planes began diving faster, climbing steeper, and tearing through the sky like nothing they'd ever seen. Luftwaffe pilots radioed in disbelief, "These Mustangs, they don't slow down." What they didn't know was that the Americans had unleashed a secret weapon, not a new engine, not a new design, but something far more ordinary, and far more devastating. It was fuel. A new kind of fuel that turned the P-51 from a fine machine into a 490-mile-per-hour demon. The German pilots had seen P-51 Mustangs before. Sleek, silver American fighters that escorted bombers but rarely caught up with their faster Messerschmitts in a dive. In early 1944, most Luftwaffe aces still dismissed the P-51 as just another Allied plane, nimble, yes, but nothing extraordinary. Then, suddenly, something changed. Their enemies began closing the gap in the sky faster than seemed possible. The new Mustangs weren't just matching them, they were overtaking them, screaming down from altitude at impossible speeds, engines howling like banshees. Reports began to filter through German radio networks: "The American fighters are faster now, impossibly faster." Pilots who tried to dive away found themselves chased down, their escape angles crushed, their arrogance undone. What none of them knew was that the Americans hadn't built a new airplane, they had changed its blood. The secret was fuel, 150-octane aviation gasoline, a liquid miracle that turned the P-51 Mustang into one of the deadliest machines of the war. On paper, the jump didn't look like much, from the already potent 100-octane to 150 grade, a number that meant little to most outside the engineering corps. But inside those engines, it meant everything. It meant the difference between power and overboost, between 1,400 horsepower and over 1,800. It meant the Rolls-Royce Merlin engine, already a masterpiece, could run hotter, climb faster, and drive the Mustang beyond the limits the Germans thought possible. It meant a top speed of nearly 490 miles per hour, faster than any fighter the Luftwaffe could put in the sky in 1944. This transformation began quietly in the laboratories of the Anglo-American alliance, long before the first drop was poured into a Mustang. Engineers at the Anglo-Iranian Oil Company, Esso, and Shell had been racing to develop new high-performance fuel blends since the early days of the war. In Britain, chemists at Shell's Thornton Research Center were experimenting with lead additives and aromatic hydrocarbons that would allow engines to handle higher compression without detonating. The result was an ultra-refined gasoline that resisted knock even under extreme pressures, an invention as critical to air power as radar or the proximity fuse. The problem was supply. Producing 150-grade fuel required vast refining capacity and precise control of additives that only the United States could manage at scale. By 1943, the Americans had built that capacity. Massive refineries in Texas, Louisiana, and New Jersey churned out the world's most advanced aviation fuel, packed in drums and shipped across the Atlantic. The first tests began with the RAF Spitfires and American Thunderbolts in Britain. Pilots who used it came back wide-eyed, describing performance jumps so sharp it felt like flying a new aircraft. When engineers ran the data, they saw it confirmed: higher manifold pressures, more horsepower, faster climb rates. But the big question was whether the Mustang's Merlin engine could safely handle it under combat conditions. At bases across England in early 1944, that question was answered the only way it could be, by experiment, in the air. In February, small squadrons of P-51Bs from the 8th Air Force began receiving drums of experimental fuel labeled 100/150. It was a hybrid blend, 100-octane base stock doped with toluene and tetraethyl lead to reach a wartime rating of 150. Ground crews were warned to log everything: engine temperatures, knock behavior, spark plug wear. The early reports came back with a single word: outstanding. Pilots could push their throttles forward past the red line, into realms previously forbidden by engineers. The boost gauges spun higher, and the Mustangs responded like animals unleashed. In a climb, the P-51s could now reach altitudes faster than the German Focke-Wulf 190s, and at full power, their acceleration was breathtaking. When the first combat tests came, the Germans didn't know what hit them. Over the skies of Germany in March 1944, during missions escorting B-17s to Berlin, Luftwaffe interceptors swooped in expecting the usual slow-rolling American escorts. Instead, they met Mustangs that seemed to defy physics. They could dive and then climb again without losing speed. Pilots like Chuck Yeager and Bud Anderson began to realize they could now chase German fighters all the way through their escape dives, something unthinkable just months before. In his logbook, Yeager wrote simply, "This ship climbs like a homesick angel." From the ground, German radar operators and observers were equally stunned. Reports from air defense sectors around Frankfurt and Hanover described new American fighters with unprecedented acceleration. One commander complained that, "Our aircraft cannot disengage, they pursue relentlessly." To German intelligence, it looked like the Americans had secretly introduced an entirely new model of fighter. But aerial reconnaissance revealed nothing. The same P-51s kept appearing, the same silhouettes, the same wing markings. The mystery deepened. Behind the scenes, Allied intelligence did everything possible to keep it that way. Reports about 150-octane fuel were classified, the barrels themselves disguised, and the mechanics sworn to secrecy. Even pilots were told not to discuss the performance jump outside their briefings. The code name used in documents was simple and bland, improved fuel supply. But those who flew with it knew it was something extraordinary. They began calling their Mustangs hot ships, a nickname whispered with awe around the airfields of East Anglia. As the Allied bombing campaign intensified through spring 1944, the true impact of the 150-grade fuel began to show. The 8th Air Force's losses began to drop. German pilots who had once hunted bombers with impunity now found themselves hunted instead. The sky, once a place where the Luftwaffe ruled at high altitude, was turning against them. In the briefing rooms, American commanders began to see something remarkable in the mission data. Squadrons running the new fuel were outperforming all others, higher sortie success rates, longer range, fewer mechanical failures. The invisible upgrade was working better than anyone had dreamed. By the time the Germans began to suspect that something mechanical was behind their defeats, it was already too late. The 150-octane revolution had taken flight, and the P-51 Mustang, once just another Allied fighter, was becoming a legend. The Germans had built faster planes before, deadlier weapons, more powerful engines. But they had never imagined that chemistry itself could be turned into a weapon, and that a colorless liquid, refined in quiet factories across the ocean, could change the balance of air power over Europe forever. By the summer of 1944, the skies over Europe had changed. The P-51 Mustang, once just another fighter in the Allied arsenal, had become a predator. The Luftwaffe still fought ferociously, but the air war was shifting, and few on the German side truly understood why. From their vantage, the Americans had somehow multiplied their speed, tightened their formations, and sharpened their edge overnight. In truth, what had changed was invisible to the naked eye. It wasn't the wings or the guns. It was what flowed through the veins of those engines, a 150-octane heartbeat that transformed every flight into an experiment in controlled fury. The rollout of this new fuel had begun quietly in early 1944, but by June, the month of D-Day, it was everywhere the U.S. Army Air Forces operated. Tankers arrived at bases in England under heavy guard, the barrels marked with cryptic labels to disguise their purpose. Even among the ground crews, only a handful of officers knew exactly what they were handling. Most believed it was a new, high-grade blend to improve reliability before the invasion. In reality, it was the single most powerful aviation fuel ever burned in combat up to that point. At the forward airfields of East Anglia, mechanics drained the old 100-octane from their fighters and replaced it with the new brew. When pilots returned from their first missions using it, the difference was undeniable. They described acceleration that slammed them into their harnesses, climbs that felt endless, throttle response that turned seconds into fractions. Engineers studying the flight logs realized that the Mustang's climb rate had improved by more than 1,000 feet per minute, and that sustained high-power runs were now possible without destroying the engine. But the real advantage wasn't just speed, it was versatility. The P-51's Merlin engine, designed by Rolls-Royce and built under license by Packard in Detroit, was suddenly more than a machine of war, it was an adaptable platform. The new fuel allowed pilots to push war emergency power beyond its old limits, 67 inches of mercury manifold pressure instead of 61, without knocking, detonation, or failure. Every extra inch meant a leap in horsepower. Every leap meant life or death in a duel measured in seconds. The results began to ripple through the air campaign. The long-range escort missions to Berlin and beyond, once plagued by staggering bomber losses, started to turn. Where once hundreds of B-17s had flown alone into flak and fighter hell, now P-51s could stay with them all the way to the target and back. In April 1944, the 8th Air Force lost one bomber for every 14 dispatched. By July, that number had dropped to 1 for every 42. The Mustangs were no longer just guards, they were hunters. German pilots began noticing the change in unnerving ways. High over the Reich, the thin-air duels that had once been their playground were becoming death traps. The Mustang's ceiling was higher now, its throttle response faster. Veteran Luftwaffe ace Adolf Galland wrote after the war that by mid-1944, the Americans seemed to have endless power, endless speed. It was as if their engines were bewitched. Even experienced German flight leaders misjudged closing speeds, their calculations, based on months of combat data, rendered obsolete by chemistry. On the ground, the confusion deepened. Reports flowed into Luftwaffe headquarters describing modified Mustangs with supercharged engines. Intelligence officers scrambled to investigate. Intercepted Allied communications revealed nothing. Factory inspections of captured wrecks showed no changes to design or structure. Some analysts concluded that the Allies had secretly introduced a new type of propeller, or even begun deploying jets in disguise. Few guessed the truth, that the Americans had simply changed what they poured into their tanks. For the pilots, the difference was both a thrill and a burden. With great power came new dangers. The Merlin engine could handle the boost, but only if carefully managed. Pilots were warned that exceeding the new limits too long could tear the engine apart. Still, in the heat of combat, restraint was a luxury few could afford. Many came back with cylinders scorched, spark plugs fouled, and oil temperatures pegged in the red. But they also came back alive. One ace later said, "I'd rather blow the engine and get home than save it and die polite." At the tactical level, the new fuel changed how air battles were fought. Before, Allied fighters had to rely on numbers and positioning to survive German ambushes. Now they could seize the initiative. In a dogfight, the ability to climb faster or extend in a dive meant controlling the engagement entirely. German pilots, used to dictating when to fight and when to disengage, found that advantage ripped away. Every time they tried to escape, the 150-grade Mustangs followed, their engines roaring, their wings slicing through contrails. Allied commanders quickly realized what they had. In June 1944, as the invasion fleet assembled for D-Day, P-51 groups using the new fuel were chosen to provide deep escort coverage. They flew far beyond the beaches, patrolling over bridges, roads, and rail lines to choke off German reinforcements. With the new range and performance, they could loiter over France longer, respond to calls from ground forces, and dive into strafing runs with a speed that made them almost untouchable. German ground troops reported seeing Mustangs arrive seemingly out of nowhere, striking convoys and trains before vanishing into the clouds. To them, these aircraft were not machines, they were phantoms. Some even speculated that the Allies had developed aerodynamic rockets. Rumors spread through the Wehrmacht that America had found a way to cheat physics itself. In reality, the Americans had done something subtler but far more elegant. They had weaponized chemistry. In a war of industrial production, where tanks and planes could be counted by the thousands, the true battlefield had shifted into the realm of refinement, research, and invisible innovation. The P-51 was proof that sometimes, the smallest changes, a few extra points of octane, could alter the course of history. And by the time the Germans finally began to understand what had happened, the Mustangs were already overhead, engines screaming, their wings flashing in the sunlight, chasing their enemies down with the invisible power that no amount of armor or arrogance could withstand. In the summer and fall of 1944, confusion spread through the Luftwaffe like smoke through a broken engine. The reports were consistent but unbelievable. The Americans' P-51s were climbing faster, diving harder, and flying farther than physics should have allowed. In pilot debriefings, German aces described the same phenomenon again and again: Mustangs that refused to slow down, bombers escorted all the way to Berlin, and squadrons of enemy fighters appearing out of nowhere, high above their formations. For the German High Command, it was more than a tactical mystery. It was a crisis of perception. The Reich had built its identity on technological superiority, and now, without warning, it had lost control of the sky. At first, Luftwaffe intelligence officers dismissed the complaints. They blamed weather, pilot exaggeration, or simple bad luck. After all, the Mustang was a known quantity, an agile but fragile escort fighter, powered by a Merlin engine that the Germans themselves had studied from captured wrecks. Its limits were well established. Or so they thought. But by mid-1944, those limits no longer applied. Pilots of the elite Jägerschwader 26, veterans of the Battle of Britain, began reporting that their Bf-109s could no longer outclimb or outdive the enemy. One squadron leader wrote, "It is as if the American machines have become enchanted, they gain altitude like balloons and dive like stones." In the laboratories and testing centers of the Reich, engineers began searching for answers. Captured Mustangs were analyzed in meticulous detail. German mechanics measured every cylinder, every spark plug, every manifold. They compared propellers, superchargers, and exhaust ports, looking for hidden modifications. Nothing. The planes were identical to those they had faced months earlier. That left only one possibility: something was different inside the engine. But when fuel samples were drawn from downed aircraft, the tests came back inconclusive. The Americans were using a higher-grade aviation fuel, but the exact composition was beyond the Reich's refining capability. Germany's own fuel situation was already desperate. The Allied bombing campaign had crippled synthetic fuel plants, cutting production by more than half. By late 1944, the Luftwaffe was running on fumes, literally. The standard fuel available to frontline squadrons was around 87 to 95 octane, far below the performance threshold of the American blend. Engineers tried to compensate by experimenting with methanol water injection systems and emergency boost controls, but these were temporary fixes. High-performance engines like the Daimler-Benz DB605 or Junkers Jumo 213 could reach extraordinary power levels for a few minutes, but only at the cost of reliability. Pistons cracked, valves burned, and entire engines seized mid-flight. The Americans, meanwhile, could sustain their war emergency power for as long as fuel lasted. Inside the German command structure, frustration turned to disbelief. The Luftwaffe's once elite fighter corps was being chewed apart not by superior tactics or numbers, but by an invisible advantage they couldn't replicate. Allied pilots seemed to maneuver with endless confidence, climbing to altitudes where Messerschmitt sputtered and Focke-Wulfs lost thrust. In many dogfights, the Germans never even saw their killers. They were hit from above, out-accelerated in dives, and left spinning through the clouds before they could react. To counter this new threat, the Reich doubled down on innovation. The Me-262 jet fighter, already in development, was pushed into combat even before its teething problems were solved. It was fast, faster than anything in the sky, but its engines were fragile and its fuel demands extreme. Each sortie drained what little high-grade stockpile Germany had left. Meanwhile, propeller-driven fighters were retrofitted with nitrous oxide systems, nicknamed GM-1, that briefly boosted power at high altitude. But it wasn't enough. The Mustang's advantage wasn't temporary, it was systemic. Its pilots didn't need to gamble with their engines. They were operating at full power every day, sustained by an endless ocean of 150-octane gasoline shipped from refineries thousands of miles away. In intercepted communications, German analysts began to notice peculiar patterns in Allied maintenance logs. References to 100-150 fuel appeared repeatedly, often alongside notes about performance tests and manifold pressure settings. At first, these reports were dismissed as clerical errors. Nobody believed that a jump from 100 to 150 octane was even chemically possible. But when Luftwaffe scientists revisited their own research, they realized the Americans might have achieved something extraordinary. Through complex refining techniques using iso-octane, toluene, and lead additives, they had created a fuel so stable that engines could operate far beyond their original design limits. The realization came too late. Even if Germany had understood the secret, it lacked the industrial capacity to copy it. Synthetic fuel plants relied on coal hydrogenation, which couldn't produce high-octane fractions in large quantities. Every refinery the Allies bombed meant fewer gallons, less mobility, and fewer sorties. As American Mustangs roamed deeper into German airspace, escorting bombers to Munich, Vienna, and Prague, the Luftwaffe's presence thinned to scattered pockets. Some German units grounded half their planes for lack of fuel. Others trained new pilots in simulators powered by bicycle pedals because they couldn't spare real aviation gasoline. In the air, the effects were brutal. American bomber formations that had once taken catastrophic losses now punched through with devastating precision. The skies over Schweinfurt, Hamburg, and Dresden became killing grounds, not for the bombers, but for the interceptors. Pilots like John C. Meyer and George Preddy racked up staggering kill counts, chasing their prey with newfound confidence. Preddy's own P-51, Mighty, achieved speeds German radar couldn't even track accurately. One surviving German pilot later admitted, "We could not fight them anymore. They were always faster, always higher. It was as if they had endless energy." For the Allies, this unseen advantage became a quiet triumph of engineering and logistics. Few outside the inner circles of command ever knew why the tide had turned so dramatically. Newspapers credited better tactics, superior training, or sheer numbers. Only a handful of chemical engineers and refinery technicians understood that the real weapon had been born not in a factory of steel, but in a vat of liquid fire. By the time the first German scientists pieced together the truth, that America's refinery capacity had unlocked a chemical edge no aircraft could counter, the war was already slipping away. The Luftwaffe's once mighty force was grounded by shortages, its surviving aces shot down by Mustangs that flew faster, higher, and longer than any piston engine in history. In the end, the Germans realized too late that the battle for the skies had not just been a war of machines, it had been a war of molecules. By June 1944, the thunder of engines filled the air over southern England. From every airfield came the roar of thousands of planes being readied for Operation Overlord, the Allied invasion of Europe. Pilots were briefed, mechanics double-checked fuel lines, and across the runways stood endless rows of P-51 Mustangs gleaming in the dawn light. For the men who would fly them, there was no sense of luxury in the preparation. Every mission carried the weight of history. But behind the noise and motion, one silent revolution was already in motion, inside the fuel drums that lined the airstrips. Every aircraft scheduled to support the invasion was loaded with a new kind of gasoline, 100/150 grade fuel, developed in secret, refined in vast American plants, and shipped across the Atlantic in quantities so enormous it strained logistics to the limit. It was volatile, dangerous, and priceless. Engineers joked that a single drum of it was worth more than gold, and in June 1944, it very nearly was. The coming invasion would hinge on more than ships and soldiers. It would hinge on control of the sky. As dawn broke over the beaches of Normandy on June 6, that control was absolute. Overhead, the roar of Allied air power drowned out the sea itself. Fighters, bombers, and reconnaissance planes moved in precise choreography, weaving above the invasion fleet. For the Germans, whose radar screens lit up with swarms of approaching aircraft, it was an unimaginable sight, a wall of wings stretching from horizon to horizon. And at the center of that storm, leading the charge over the beaches and inland roads, were the Mustangs. The Rangers storming Point du Hoc, the paratroopers of the 101st trapped at St. Mireglès, the infantry pinned down on Omaha Beach, all of them felt the same thing that morning, the hum of friendly engines overhead. The P-51s slashed through the clouds, strafing supply convoys, knocking out armored columns, and intercepting Luftwaffe fighters before they could reach the beaches. Their speed was unmatched, their endurance seemingly endless. German reports described them as everywhere at once. For the defenders, it felt like the very air had turned against them. What few realized at the time was how directly the new fuel had enabled that dominance. With 150-grade gasoline in their tanks, the Mustangs could climb faster to meet threats, stay aloft longer to protect the fleet, and respond instantly to calls from the ground. A single squadron could pivot from air patrol to close support in minutes, covering miles of territory that would have taken earlier models an hour to reach. The synergy between range and responsiveness made them not just escorts but guardians of the entire invasion front. Luftwaffe pilots who scrambled to meet them faced an impossible fight. Short on fuel, short on ammunition, and increasingly short on hope, they climbed into the sky with machines that could barely match the performance of their enemies. German analysts had already realized by then that the Allies had a new type of fuel, but there was no way to replicate it. The bombing of synthetic fuel plants had crippled Germany's supply chain, and the Luftwaffe was forced to ration aviation gasoline so heavily that many squadrons could only fly a handful of missions each week. The imbalance was devastating. The Allied air fleet ran on a chemical cocktail of perfection, and they had oceans of it. The Germans were running on fumes. The very thing that powered the invasion, fuel, had become both the weapon and the target. As the Allies advanced inland from the beaches, Sherman tanks rolled forward with drums of the same high-octane mixture that powered the skies above them. It was chemistry turned into strategy, logistics turned into supremacy. By July, as Allied armies broke out of Normandy, the air war over France became a massacre. The Luftwaffe tried to reassert control, launching desperate sorties of FW-190s and Me-109s, but the response from the Mustangs was instant and merciless. In one battle over the Falaise pocket, squadrons of P-51s dove on retreating German columns, their guns spitting fire across the roads. Tanks burned, trucks exploded, and infantry scattered under the relentless strikes. German soldiers later recalled looking up to see silver wings diving out of the sun, their sound so constant it seemed like the sky itself had a heartbeat. Every mission flown, every sortie launched, was a symphony of coordination made possible by communication and fuel. The Mustangs could range deeper than ever before, maintaining air superiority not just over the beaches but hundreds of miles inland. The Luftwaffe, trapped by geography and starvation, could no longer contest them. For the first time in the war, Allied bombers flew to Berlin and back with minimal interference. The psychological blow was immense. To the Germans, who had once ruled the skies over Europe, it was proof that their era was over. Even in the months after D-Day, the effects of 150-grade fuel continued to ripple across the front. In August, as Paris was liberated, the skies were filled with Mustangs sweeping low over the city, their engines still running on the same formula that had carried them across the Channel. For the air crews, it was more than just performance, it was confidence. They could outfly anything the enemy sent at them. One American pilot put it simply, "We felt invincible. Whatever they threw up, we could climb past it, outrun it, or burn it down." For the Germans, it was an agony of disbelief. Their once feared Luftwaffe had become a shadow of itself, its aces picked off one by one, its fuel reserves drained by retreat. Engineers in secret facilities still searched for a miracle, a new jet, a new fuel, a new weapon, but time had run out. The invisible power running through the veins of the American war machine was unstoppable. In those summer skies of 1944, the roar of the Merlin engine was more than just the sound of victory. It was the sound of chemistry triumphing over engineering, of innovation buried inside every drop of fuel. The Germans had thought altitude, armor, and firepower would decide the war. The Allies proved that sometimes, the smallest molecules could decide the fate of nations. By early 1945, the war in Europe had become a race that only one side could still run. The German army, once the terror of the continent, was retreating on every front. Its tanks sat idle for lack of fuel. Its aircraft, the once proud Luftwaffe, was reduced to scattered squadrons flying from makeshift airfields carved into forests and fields. The roar of engines that had once filled the skies over France and Poland now came mostly from the west, the deep, confident thrum of American and British aircraft sweeping eastward toward the heart of the Reich. And among them, leading the charge, were the P-51 Mustangs, sleek, silver, and unstoppable. In those final months, the Mustang was more than just a fighter. It was a symbol of inevitability. Every time a German pilot climbed into his cockpit, he knew that somewhere above him, perhaps 10,000 feet higher, perhaps just beyond the next cloud, there was a Mustang waiting. The Luftwaffe's last reserves of experienced pilots were being burned away, their training programs crippled by lack of fuel and aircraft. New recruits were sent into the air with barely a few hours of flight time. Against them came American squadrons that could fly almost daily, sustained by the same invisible advantage that had turned the tide a year before, 150-grade fuel. At German airfields, the reality was grim. Crews rationed gasoline to keep a handful of planes operational. Mechanics stripped down wrecked aircraft for usable parts. Many of the jets that could have changed the balance, the revolutionary Messerschmitt Me-262s, sat grounded because there simply wasn't enough high-octane fuel to feed them. The irony was painful. Germany had developed some of the most advanced engines in the world, but it no longer had the means to power them. Meanwhile, across the Channel and the Rhine, American refineries were producing 150-octane gasoline by the millions of gallons, filling drums, pipelines, and fuel trucks that followed every advancing column. The results were mercilessly visible in the sky. American bombers flew with almost impunity, escorted deep into the heart of Germany by Mustangs that could chase enemy fighters all the way to their home bases and back. Rail yards, oil refineries, and bridges were reduced to smoking craters. Columns of German trucks and tanks moving by night were tracked and annihilated by P-51s equipped with long-range tanks and radios that linked them directly to ground controllers. The air war was no longer a duel, it was an extermination. To the German soldiers on the ground, it felt as if the Mustangs were everywhere at once. They attacked from above the clouds, swooped down on convoys, and vanished before anyone could respond. Prisoners later described the terror of the silver planes that appeared out of nowhere, strafing and bombing with impossible precision. Some soldiers called them the angels of death. Others simply stopped looking up. Inside those Mustangs, the pilots knew they were witnessing the end of something. They were flying through the ruins of the Luftwaffe, the same force that had once seemed invincible. Many of them had entered the war when Germany dominated the air, now they were watching it burn out in the cold sky. "We owned the air," one pilot later recalled. "There was nothing left up there but us and the wind." Behind the scenes, scientists and engineers were already studying what had made that dominance possible. The 150-octane fuel had proven so effective that it became a benchmark for post-war aviation chemistry. Its ingredients, iso-octane, aromatic hydrocarbons, tetraethyl lead, and other additives, were studied, refined, and adapted for jet engines that would soon take over the world's skies. The lessons learned in 1944 about detonation control, thermal stability, and power-to-weight ratios laid the groundwork for the next generation of propulsion. The race for better fuel had begun as a wartime necessity, but it ended as the foundation of the jet age. For Germany's surviving engineers, the revelation was staggering. After the war, many of them joined Allied research teams or were captured and interrogated by technical missions. They were shown the specifications of the American fuel they had faced, the refinery techniques, the chemical additives, the sheer scale of industrial production behind it. One Luftwaffe chemist reportedly remarked, "We never had a chance. You didn't just outfly us, you outbuilt us." It wasn't arrogance that had doomed them. It was logistics. It was science. By April 1945, as Allied troops crossed the Elbe and Berlin burned, the last remnants of the Luftwaffe were grounded. Fuel reserves had run dry, pilots were told to save their aircraft for decisive moments that would never come. The skies were now ruled entirely by the Allies. The Mustangs, flying patrols over shattered cities, became a constant reminder of how the war had been won, not only with courage, but with chemistry. The invisible power that roared through their engines had done more than speed them to victory. It had reshaped warfare itself. When the war finally ended, the P-51 was hailed as one of the greatest fighters in history. Its range, speed, and agility were unmatched among piston-engine aircraft. But its true secret, the lifeblood that gave it wings, remained largely unknown to the public. Newspapers praised its pilots, its design, its elegant silhouette. Few mentioned the colorless liquid that had turned it into a 490-mile-per-hour demon. Yet in laboratories, refineries, and military archives, the truth was clear. The Allies had not just built better machines, they had built better fuel for them. Years later, as jet engines replaced propellers and supersonic flight became reality, the lessons of that high-octane war lingered. Every new aircraft, every experimental engine, carried echoes of the P-51's triumph, the understanding that power begins not in the airframe, but in the chemistry that drives it. For the Germans, the realization was sobering. Their brilliant engineers had built machines ahead of their time, but they were trapped by scarcity. For the Americans, it was a revelation, that in modern war, science and industry were as decisive as soldiers and strategy. The 150-grade fuel had not just powered a plane. It had powered a victory, one that started in the laboratories and ended in the skies over a defeated empire. And somewhere, above the clouds of 1945, the Mustang still roared, ghosts of speed and steel, carrying with them the invisible miracle that had changed the world forever.